Good morning, guys. Today we're going to start our lesson with a warm-up recapping what we learned yesterday. So please pause the video while the students have a chance to try the problem. Alright, let's see how you did. Our correct solution would be just 0. Hopefully you saw that you needed to factor out the cosine and then set cosine theta equal to 0 and secant theta equal to 0. We solve each of these mini problems and we get pi halves, 3 pi halves, and 0. However, even though pi halves and 3 pi halves are valid solutions for cosine, they are not valid solutions for secant. And the reason why this is because pi halves and 3 pi halves are undefined for secant of x. And so even though they are valid solutions for cosine, they are not valid solutions for the entire problem. So we have to cross them off. Therefore, the only solution in the entire circle of 0 to 2 theta that works for us is 0. Alright, today we're going to focus on not only solving equations, but also what to do when all of the answers we find don't work. So I have two bits of advice for you. The first is to be careful of secant, cosecant, tangent, and cotangent. And we need to really be careful of these because these functions can be undefined. So if we have a problem where we have, say, secant of x and tangent of x, or secant of x and cosine of x, we have to make sure that any solution found can work in all parts of the problem. The second thing that we have to worry about is when we square both sides of an equation. And we'll take a look at using that method today. We talked about yesterday that when you square both sides, you can do a substitution with your Pythagorean identity. And when you do that, you open yourself up to extraneous solutions. So you always have to check to make sure that those solutions work in the original problem. We're going to go ahead and get started. On our first example, we need to solve for theta. And for both of these, theta will be within the in radians from 0 to 2 pi. And looking at this problem, we can notice that secant can be written as 1 over the cosine of theta. And from here, if we multiply all terms by cosine of theta, then what we'll end up getting is a quadratic that we can solve. So multiplying everything by cosine of theta gives us 2 cosine squared theta plus cosine theta equal to 1. Now whenever we have our quadratic, like we talked about yesterday, we need to set it equal to 0 and then try to factor or do quadratic formula. Alright, pause the video and let the students finish the problem. And we end up getting that theta equals pi thirds, 5 pi thirds, and pi. Since none of these values make secant undefined, they are all valid solutions. In our next problem, we have a fraction equal to 0. The only way that a fraction can equal 0 is if our numerator equals 0. We completely disregard the denominator because if the denominator were 0, the problem would be undefined. And sine squared theta is equal to 0 when sine theta is equal to 0. And sine is equal to 0 at 0 and pi. Now we double check to make sure that these values are not undefined for secant. Since secant is r over x, and at, geez, my computer is dying, and at 0 radians and pi radians, x is not 0, then these answers are valid. Alright, moving on. Hopefully my computer can make it through this lesson without dying. Okay, so similarly to how we did question number 1 with the cosine and the secant, we'll use the same idea here. And we can write cosecant as 1 over sine theta, and then we can multiply everything by a sine theta, giving us sine squared theta minus 1 equaling to 0. And then from here, this factors. Difference of two squares, sine theta plus 1, sine theta minus 1. And then when we solve each of these, we find out that sine theta is equal to 1, or sine theta is equal to negative 1. And we are in degrees now, 0 to 360. Therefore, our angles will be at 90 degrees and 270. All right. Let's take a look at example 4. Now in example 4, this is another quadratic, and unlike the quadratic we saw yesterday, this one does not factor. So because it doesn't factor, we're going to have to use quadratic formula. Alright, even though I'm not here, I'm still going to sing for you. Opposite b plus or minus square root of b squared minus 4ac all over 2a. You like that? Okay. So remember, our variable is secant x. So we'll have secant theta is equal to opposite 3 plus or minus square root of 9 minus 4 times 1 times c, which is negative 1, all over 2a all over 2. Alright, I want you to pause the video and I want the students to go ahead and try and see if they can solve this referring to the example from yesterday. And then give them a minute or two and then unpause it and they can follow along with my work. Alright, so doing quadratic formula gives us these two solutions, 0.303 and negative 3.03. And if you recall from our the range of secant, we know that any angle is going to have a secant greater than 1 or less than negative 1. So this guy here gets crossed off. It's not possible. So then we just focus on our second one. And in order to find the angle theta, we have to use secant inverse. Now, to do a secant inverse, unless you have a fancy 89, we have to use cosine inverse. And remember, we do the reciprocal inverse function of the reciprocal. And when we plug this in our calculator, we will get 107.623 degrees. And because we are working within a whole circle, there's more than one angle that has this negative sine or secant ratio. And we know that secant is negative in quadrants 2 and 4. So what we can do is visualize the angle that we have. This angle 107 will be about here. And we want to figure out how far that angle is above the x-axis, and then we can find that difference and we can add it to the 180 to get the other angle that is below the x-axis. And so our two angles end up being 107.623 degrees and 252.377 degrees. And I apologize in advance if any of these decimals are wrong. I'm just going off of my note sheet from last year. Alright, please pause the video so everyone can talk with their neighbors, make sure they got what's going on, and if so, we'll go ahead to the last example. Alright, last problem. Now, if we look back at the examples we did, in examples 1 and 3, we found it useful to write in terms of the reciprocal function and then multiply so that we had a quadratic. In example 4, our quadratic was all the same function, so we were able to do quadratic formula. Here, however, we don't have reciprocal functions, and we don't have something that we can factor or do quadratic formula. So for that reason, our best bet here is to square both sides. And the reason why I thought to do this is because tangent and secant are connected with a Pythagorean identity. So we're going to square both sides, and remember, you have to FOIL. So on the left, we apply our squaring pattern. Squaring the first term, double the product, squaring the last term, and then equals secant squared x. And then now we're going to replace, and we're going to replace secant squared x with tangent squared x plus 1. So we're going to take this guy and sub him in with this guy. And so now that gives me tangent squared x plus 2 root 3 tan x plus 3 equals tangent squared x plus 1. And then check that out. Tangent squared x cancel. So I get 2 root 3 tan x equals, well, minus the 3 over, negative 2. And then we continue solving for the tan x and rationalize. And voila, we get negative root 3 over 3. Alright, so now we're dealing with radians. we want to figure out, all right, let's go in back of our brains, where are all the angles in 0 to 2 pi that have a tangent ratio of negative root 3 over 3? And that would be in quadrant 2 and 4 at 5 pi 6 and 11 pi 6. And now we must check our answers. Whenever you square both sides, you must check your answers. Okay? And when we check them, we plug them in the original problem. So if we check the 5 pi 6, we'll do tangent of 5 pi 6, which gives us negative root 3 over 3 plus root 3. And then we do secant of 5 pi 6, which gives me negative 2 root 3 over 3. Now, when I'm adding these fractions, I know we hate fractions, but we can handle this. This is a root 3 over 3. That's the same thing. And then negative 1 plus 3 gives me 2 root 3 over 3, which is not equal to negative 2 root 3 over 3. So right now we have shown that the 5 pi 6 does not work. Next, let's check our 11 pi 6. And for our 11 pi 6, we also get the negative root 3 over 3 plus the 3 root 3 over 3. And then in the fourth quadrant at 11 pi 6, our secant here is positive. So now this equals positive 2 root 3 over 3. And now we have a winner. Voila! Like I said yesterday, these problems really put everything together. Okay, I'm going to have Mrs. Schumann today, go ahead and put the solutions up from the last 2 nights of bookwork from 6-1, day 1, and 6-1, day 2, so you can have the evens available. Last night's homework was odds, tonight's homework is odds. So for the rest of the period, I want you to get your desks and your groups, go over homework questions, and be efficient. This stuff is not easy, and you're going to have to work hard at it. All right, so here are the solutions for the homework. All right, there we go. And then if you can just please freeze the screen and leave this up there.